TwinGate provides zero trust, identity based access to your cloud and on prem resources without the need for a pesky VPN.
Learn more about how TwinGate can help solve your remote access problems at the break.
Packet pushers.
Welcome to Day 2 DevOps, where the DevOps is in the details. I'm Ned Bellavance, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on day one and beyond. With me on this journey of learning and doing is my co-host, Kyler Middleton. Hi, Kyler.
Hey, Ned. Today we had Dr. Nick Feamster on the show who talked about all sorts of stuff in terms of data science and network management across the United States, and it was fascinating. We talked about how Arthur C. Clarke put it best: any sufficiently advanced technology is indistinguishable from magic, and we talked about all the magical networking that exists all around us and the data that we collect from it. We talked about all the layers that you can dig into for all the technologies that are around you, and there's always more layers. All of our modern technological marvels are built on magic and engineering from past folks, and that technology alone isn't enough. Even if you do it brilliantly, you need to involve everyone to advance real change.
Nick is a Neubauer Professor of Computer Science at the University of Chicago, Director of Network Operations and Internet Security Lab, founder and co-director of the Internet Equity Initiative, and Director of Research at the Data Science Institute. Nick is a busy guy, and we're honored he could take some time from his schedule to chat with us. So without further ado, here's Dr. Nick Feamster. Well, Nick, welcome to Day 2 DevOps. We're pretty excited to have you here. It's taken a little while, long and winding road, but we finally got here.
I know.
As preparation, I was reading through your many accomplishments. You're a professor at University of Chicago, founder and co-director of the Internet Equity Initiative, director of research for Data Science Institute. The list just kept on going. But the absolute most important thing is that you graduated from MIT, and my son wants to go there. So can you pull some strings for me?
It's been a while. I know some people. Sometimes they answer my email, but most of the time they don't.
Well, thank you for being on the show. It's been great to have you.
We'll see what I can do. But it's a great school.
Excellent. He's 13 now, so he's got a little bit of time. I might reach out in like 4 years and be like, hey.
It's about the time that I decided that place seemed pretty cool. And I think it's only gotten better. So
yeah. Awesome. That is great to hear. Well, let's talk about some other things that may be more relevant to our audience. I was looking through all of your accomplishments. The unifying themes that I kept seeing in your endeavors were a focus on networking and its measurement and analysis. So where did that passion come from?
You know, I've never quite thought about that at length. I think I'll start with some things that fascinated me. I think I've always been super fascinated by the internet and by networks. I remember very, very early on, like maybe in my late teens, and I built my first socket-based network. I just thought it was the coolest thing that you could like type something over here and then it would like show up and it was just like a machine across the room. And I was like, that, to me, that it was like magic. I want to know how that works. And then I think like for the other stuff too, I mean, we'll get into it, I'm sure, but, fast forward to my it's probably 29, 30. One of my PhD students, he was like, I think we can use machine learning. This was like 2008, 2007, 2000. We can use machine learning to do prediction of like certain kinds of like application response times or whatever. And I'd done some machine learning like on spam filtering, malware detection, things like that, which is fairly straightforward. But, this thing, it was like he was working as an intern at Google at the time. It's like, wow, you could predict the distribution of search response times, like, and how they would change based on like changes in the configuration. I mean, now we're like, yeah, of course. But like, this was 2008. And I was like, it's kind of like the socket thing. I was like, this is like magic, like,
Right.
how does that work? And at the time, like I said, it's 2008. And it's all, skeptics. They're like, no, we need closed form solutions. We need this, this is just like some hocus pocus. And it kind of was, but I think it sort of always fascinated me. And I was like, I really want to know how this works. And I think everything that I do, in life, from my day job to my hobbies and stuff, it's always like a fascination with how something works. It's like, how did they do that? How does that work? So I think it's that. And then the other thing too is like I've always liked computers and, systems and things, but I've never been like an awesome coder. Like I did kernel hacking in grad school and stuff. And it's just like not that great of a software developer, but I like writing code. I find it pretty meditative. And like I think it's like what was the quote from Annie Hall? It's like those who can't do teach, and those that can't teach gym or something. It's like those that like can't build like measure or something, and those that can't measure like teach measurement or do measurement research. So yeah, maybe it's something like that.
Wow. So going back to that Google example, I mean, what was he even collecting to get that information? Was it like packet captures or flow captures, or not that you necessarily remember, but that had to be hard to capture and then also like actually analyze.
It was packet captures. It was like full packet captures. And I remember actually some discussions about when we were working on that project. Because again, he was interning at Google. Obviously, he worked there. So he had to have like that kind of access to that data. And back then, it was like tough to get packet captures at all, at line rate, let alone so much of them, and to like store them, process them. And I remember like the other collaborator on the project, the other like university professor, his code advisor, was like, yeah, this is pretty awesome, but like only Google would be capable of doing this because nobody has like data or the compute or whatever. So like, cool, I guess, right? But like, I don't know, fast forward, like it's 2024 now. Is that 16 years later or something? And it's like, no, like packet captures are like technically possible to take, store, compute has gotten, a lot more abundant. I've got a startup company in this area that's basically working on these things. And so I think it was like interesting at the time, like 2008, we're like, yeah, this is cool, but this is kind of like a novelty. And like, yeah, we'll write this thing, but like only Google is ever going to do something like this. But who knows? Like maybe. And now it's like, I look back at that and I was like, yeah, that's kind of where it all started. I didn't know anything about it at the time, but like I think that has now really affected me, which by the way, I think testament to like why I love this job. In addition to many of the things I do, is that like increasing, I mean, even all the way back then, a lot of the things that I end up working on and doing are because students come with a crazy idea. And I'm sure we'll talk more about that throughout the podcast, but it's a really cool aspect to the job is that like the teacher becomes the student more often than not.
I think that is just always true where someone gets stuck somewhere and they say, can you help me with that? And you say, well, sure, I've worked on that before. And they're working on something you've never touched because like this area is so broad, technology is. I wanted to reference your throwback to just digging into something that you're interesting about and finding out the amount of complexity and the amount of almost literally magic. I have a CCNA in wireless stuff and learning about like orthogonal radio waves and how things can talk just for your Wi-Fi to work at Starbucks. And it's just absolutely magical that any of that engineering works at all. And there's so many domains where it just makes so much sense in networking when you type something and it appears somewhere else. But that's so many drivers and electrical transmissions and so much magic to make happen. I just think it's great to be surrounded by things that you can dig into and find hundreds of layers from thousands of engineers.
Yeah, it's so cool. I mean, like you never quite lose the capacity for wonder, right? And I think that's the cool thing about the field that we work in as well. It's like, I mean, I see you have kids, like based on your background, I do as well. And it's like when you're of a certain age, like everything seems like magical and amazing. And I think like that's how networking has been for me too. And that's how like applications of machine learning to networking have been as well. And it's like so many things I've worked on. Let's pick a couple examples. I had this idea that I was going to like back in like 2004, 2005, apply machine learning to routing measurements and various network measurements to detect spammers. And my own PhD advisor was like, cool idea, but yeah, that's never going to work, And I was like, yeah, I don't know, like if it's going to work either, but like, let's go for it. Let's see what happens. And then lo and behold, it worked. And then like now it's like, the whole industry kind of took off in that direction. But at the time it was like, machine learning on network traffic to like detect attacks? Are you crazy? Like we've got blacklists, we have malware analyzers. Like what do we need this hocus pocus for? Fast forward like 20 years, and kind of the same thing just recently happened. I mean, you spoke about some more recent projects. Like a lot of the work that we're doing in internet equity, right, involves spatial analysis of data. It's like you want to basically talk about what is internet connectivity or performance. What does it look like on the north side of Chicago versus like the west side or the south side? And so that's a question that like anybody can understand the question, but the framing of it is like, dig like just like an iota below the surface. And you're like, oh, that's not even a well-formed question. What do you mean by performance? What do you mean by geography? Or where do you draw boundaries on your geography and at what granularity and what time? So I don't know, I posed that question to a student maybe a year ago. I was like, I don't even know if we can solve this problem. I don't actually know if there's a solution, but here, like, this is interesting, Lo and behold, he came up with some really, really cool techniques to basically do spatial data analysis and clustering on geographies. And that's kind of still work in progress. But I was like, man, looking back, even where we are now from a year ago, I was like, dude, I never would have even thought this was possible. So I think it's really amazing to kind of just see things work.
Yeah. I did want to ask you about that project in particular, the Internet Equity Initiative. That one really jumped out at me as an interesting project. Can you describe what that group is working on?
Yeah, let me tell you a story actually about that. And then I'll come to like what we're currently working on. So I'd been working on internet performance measurement, speed tests, et cetera, for probably almost a decade. And a lot of the work leading up to that, from like 2010 to 2019 or so, it was all focused on single consumer, like single user, and predominantly questions of like, what is my performance? It started off with like, am I getting what I'm paying for my ISP? Like, is the speed test I'm getting, how does that match up to like a service tier or a service level agreement or what have you? And that was like a very relevant question in the early 2010s and even for, the subsequent half decade after that. We can talk about where that went, but it's sort of like evolved into like application performance and interconnects, and like the questions started to become more complicated. But I don't know. I moved to Chicago in 2019, and I was already thinking like, oh, okay, this city, this university has a long tradition of civic engagement. How can I basically couple my work and the things that I know how to do really well, like measure performance? How can I couple that with civic engagement? Like maybe there are like intersections here with social problems. So I kind of got interested in that. I read a bunch of books about the history of Chicago as far various government projects, public housing projects. So just to kind of get educated about the place that I lived in. But also around that time, when I moved here, I signed up for internet service, shall we say. And it was difficult. Like,
Okay.
At the time I lived like close to the university, pretty good neighborhood. And, first call was like, well, the tech comes, he rolls the truck to the house to do the install. And he like looks up at the poles and he's like, don't see any of our equipment in the nearest block here. And I'm like, is this how you do this? You basically, and he's like, yeah, we just kind of roll the place up at the poles. I'm like, really? You don't have like a better? Nah, we know where our subscribers are, obviously. So we know like that they're a subscriber. We just roll into a neighborhood and then see where our stuff is. And then we kind of like build it out. And then if we pass houses, like as we sign someone up, of course, we like bang, 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 we hook them up. We do the drops like as we go so that the next time someone in the neighborhood like comes, we're not in the same situation. But long story short, the closest subscriber was like more than half a block away, maybe like almost a full block away. And so they're like, and it had to go through trees and all this. So it's like, yeah, cool. We can come out here and like finish the job. And like, I don't know, how's like 3 months for you? And I was like,
No.
No. Fortunately, since I work in this area, like I was able to make some calls and my good friends actually helped me out. But it kind of put my feelers up on this because as I mentioned, I'd like been thinking about how to sort of broaden my lens a little bit. And I personally experienced the next part of the story is I go to the FCC maps, right? The Federal Communication Maps on Broadband Connectivity. You look it up and it's like, oh, these providers have this service in your area. And it's like total BS, right? Okay. It's like completely wrong.
Right.
And I'm like, hang on a sec. Like, if it's like this in this neighborhood, right? Which is like pretty good neighborhood. Then this whole map is probably just filled with bogosity. So I was like, no, we have to basically figure out how to work on this. And like, I don't know, I've been paying attention to maps for, more than 5 years because there's a bunch of bad speed tests out there also making like fairly bogus claims about like who does and doesn't have internet access. And I was like, all right, let's try to figure out what we can work on in this area. And so at the time, then I basically, teed that up and I talked to some people in civic engagement at the university. And one of them was like, hey, you should meet this professor, Nicole Marwell, who's like in, the Crown School of Social Work Policy and Practice here. She's a sociologist, like she'd probably be interested in this. She hadn't worked in this area before, but turns out her brother works for Education Superhighway. I think I got their name right. So she'd kind of had passing familiarity with it, but she works mainly in governance. Long story short, like we started to work on this and, 4 or 5 years later, like I think we've had some fairly interesting projects and collaborations with the city of Chicago, several other smaller city governments, et cetera. Like we've actually helped various cities and states work on their challenges to the FCC maps for some of the federal funding, the so-called BEAD funding. And that's also due to like our initiative director, Alexis Shruby, who's like been doing a lot of the policy outreach on that. But long story short, like when I teed that up, I was like to my computer science PhD students, in fact, and other colleagues, like, yeah, interesting, but are there like any hard technical problems there? And I was like, I don't know, to be honest. I mean, kind of like this is like, I don't know, but like it's an unsolved problem. It's socio-technical, but like there's technical and socio-technical. If it were easy, it would be solved. So like, let's kind of explore it and figure out what the hard problems are. And like, I'm sure there's some interesting technical problems in there. Sure enough, 5 years later, we've written papers on like the prevalence of Wi-Fi bottlenecks in subscriber homes across the country. We've written papers like comparing the accuracy effectiveness of different speed tests. We've written papers on quality of experience estimation for a variety of applications from video on demand, streaming video. Because one of the questions the city of Chicago put to us was, what speeds do you need that are sufficient for remote learning? Because the next thing that happened, right, was the pandemic hit.
Right. Yeah.
And people were like, oh my gosh, this internet thing is important. And like, it's going to melt down. It's going to basically, we're going to have a full meltdown. And as we know, that didn't happen. Credit to the ISPs. Actually, that did not happen by magic. That happened because so many of our ISPs have been well run and like provisioned in response. But the thing that did happen was people like, oh my gosh, there are all these people without internet. They can't like participate in life. Right.
Right.
Mm-hmm.
9 months after I had like personally had that like weird sign up experience and started to like roll the wheels on all of this, like I'd been working on it. And then suddenly this pandemic happened and people were like, oh gosh, equity, internet equity. Like we've been thinking about that. So it was like a weird like confluence of events that like caused that to kind of get as much traction as it has. And yeah, it's been a good road. I think it continues. This story is still being written there. I would be disingenuous out of saying like we have solved the problems or even any big problems yet. But I think all these little interesting problems like spatial clustering and Wi-Fi bottlenecks and other things do come up. And so, yeah, like hopefully we'll start to see it through line.
I love the story of you starting this out and picturing you having this conversation 5 years ago and saying, I don't know if this will be a hard problem. And like, here we are 5 years later, and it's become a critical, important problem for society to solve, to keep existing. And, that's where research can take you. That's interesting.
That's right. I mean, and I think the thing that I talk about, like when I just gave this talk as a distinguished lecturer at Columbia University on Monday. And one of the ways I like wrap the talk, is like, hey, this whole thing started with a really simple question, which is like, how fast is my internet?
Mm-hmm.
Right. And like conceptually, that's, first of all, anybody can understand that now, right? I mean, it's like anybody knows what that means. But even like as a computer scientist or like just as a computer systems person, conceptually, this is like super easy to understand, right? It's like, well, I'm just pushing bits across a wire and then I'm like dividing the time interval, right? Like, okay, how many bits could I push in like a particular time window? Like, anybody can really kind of understand that. I often explain it in terms of like cars moving down a freeway, right? It's like, how many cars can you push down this stretch of freeway at a time? That's throughput. How long does it take you to drive from south side of Chicago to downtown? That's latency, right? So anybody can understand this. It seems simple, seems easy. And then, 15, 20 years later, we're still working on it. And so when I talk about the work and when I talk to like, students or people just starting their careers on this kind of thing, just like find a problem that seems interesting to you, that if it were solved, you think the world might become a better place, right? Because if it's not solved, it's probably either not worth solving or not hard. But if you think it's worth solving, then probably maybe other people care too, right? So like try to think about that. And then turns out a lot of the ideas for problems I have don't come from me. Like this one, I described it that way, but like city of Chicago is like calling us up, like, so I didn't have to like think of these problems. It's like, oh, if I think it's like a problem that's kind of niggling at me and other people are asking me about it, I'm like, maybe that's hard.
It's more about noticing the problem than it is coming up with the problem.
That's right.
Then thinking, is this interesting? Do I want to pursue it? And is there a simple solution for it? And I feel like just the question of broadband and how fast can the bits move seems very simple at first, but then, okay, where am I moving the bits to and from? What networks am I hitting?
Yeah.
And I was looking on the Internet Equity Initiative website, and there's a map on there of the US, and it shows different levels of broadband access. I was really curious, where do the data points for that map come from?
Yeah, I don't know. I mean, there's a bunch of maps up there. So like I would have to go look at the website to give you like a, super definitive answer. So hopefully the listeners aren't gonna like quote me back on this. But like a lot of it, so our data comes from a number of different sources. If I'm not mistaken, I believe that map comes from Ookla. We work a lot with the Ookla has a great program called Ookla for Good, I believe it's still called. And Kathy McDonald and some other folks at Ookla help run that. Brian Darr, I think, as well, help run that program.
And this is a speed test website. Is that the data set, or do they do additional kind of research?
For your listeners, I mean, I think Ookla, maybe not everyone's heard of them, but like speedtest.net, like everybody's heard of. So Ookla's big product is speedtest.net. And so obviously they have a bunch of data on historically throughput, like quote unquote speed tests. Like now, of course, as applications have gotten more varied, diverse, and complex, like there's other things that matter. Wait and see. In any case, they have a lot of data. And so like some of those maps probably come from that. I believe that map comes from Ookla data. That does give me an opportunity to bag on our own work, though, however, for a minute, which is that part of why I wanted to get into this in the first place is that client-based speed tests are really dirty data. As far as like, even when you take a single measurement of like your speed test at home or whatever, I mean, one of the things that I do in my class, so I'm like, okay, everybody take a speed test and like fill out this Google form. Tell me what number you got, and it's like all over the place, right? And then we spend like half an hour talking about, well, why do you get varied numbers? Like, let's talk about packet switching. Let's talk about Wi-Fi contention. Let's talk about congestion. Let's talk about interference, et cetera. Let's talk about device limitations, right? Let's talk about, to your other question, path to server, which server are you measuring against, et cetera. And so even from a single point, it's like, I want to say suspect, but it's like varied, right? I mean, it's a number, but it's like, I mean, I think this is where like as a measurement person, right? This is where I find like measurement so interesting and fascinating as like for me as a researcher, because it's like I digress a little bit, right? When I started, I was like, oh, measurement, cool. You just like get some numbers, you plot them, you publish a paper, easy peasy. But like, no, it's like figuring out, and this is the part of research that like really excites me, is like the number came from a system, like a computer system in this case. So let's figure out what system generated those numbers. And let's figure out like what we can or cannot conclude from the numbers being generated based on our domain knowledge, right? Of like, well, let's think about the system that generated those numbers. Like, okay, let's talk about speed. What path? Like, how many connections were used? What are the range of devices that were measured from? Was it like tablets? Was it routers? Was it wired Wi-Fi? Was it a mix, et cetera, all these things. And then it's like, that's the part of it I find most interesting. And to the maps point, so just to close off this point, everybody wants a map. Maps look sexy, right? Yeah. Politician can like point at it and be like, look, there's my county and I'm getting screwed and like, isn't this bad? And like for years, that's how they were being used. And I'm like, given what I just led up to, I'm like, this personally offended. I'm like, yeah, it's probably true that like your internet is bad because you're complaining about it. But the data that you're using is like, it's personally offensive to me. Like, as a technologist, I'm like, this is, test is janky, like the thing, and then it's like, when do people run speed tests? When they sign up for internet and when their internet is bad. So like putting all the technical stuff aside, the sample is like wacky. So that's where, I mean, coming back to the Internet Equity Initiative, I think that's the gap that we're trying to bridge, right? Is like everybody wants a map. Like we want maps too, right? We want to reason spatially as well. We want to ask that like north side versus south side question. But let's not jump the gun, right? Like let's basically figure out, okay, we've got this funky test. that like has all these technical irregularities, and then it's got this weird temporal sampling irregularity where like people run it at weird times, and then it also has a spatial irregularity too, which is that under-resourced communities, people living in those communities tend not to run as many speed tests as other neighborhoods, and so spatially it's weird too. I think that's the story of the Internet Equity Initiative in a nutshell, really. It's like bridging the gap between the maps that like you saw and the people like, yeah, that looks awesome, to us being able to say like, and I stand behind that. Like that is actually something that you can use. And here are the things you can use it for. Here are the types of conclusions you can draw. And here are the things that either you maybe shouldn't say, or if you do, you should know what the caveats and limitations of what you're talking about.
Knock, knock.
Who's there?
VPN.
VPN who?
Thanks for letting me in and giving me access to all your stuff.
What?
Kyler, did you know that when you grant someone access through a VPN, you're basically giving them access to everything behind the firewall? That seems bad.
You know what would be better?
What?
Granting someone granular access to resources based on an identity and their security posture.
Yeah. And maybe instead of having a single VPN concentrator, you could distribute access points to where they're needed across the clouds and on-prem.
Oh, and make it outbound only so you don't have to open any pesky ports?
Yes, I could connect to my VPC resources, my Kubernetes clusters, or anything else behind a firewall.
That sounds amazing. It sounds like TwinGate. I only wish we could deploy it with Terraform because Ned and I love Terraform.
Well, Kyler, have I got news for you? You can automate TwinGate with Terraform, Pulumi, or their public-facing API.
I wouldn't leave my fate to any other company, and neither should you. Try TwinGate now for free for up to 5 users, or start a 14-day business trial at twingate.com.
I'm thinking of all the confounding factors into an internet speed test. So, I mean, there's the device itself, the difference of running it on something that has a NIC that's only capable of 100 meg. So you're never going to get a speed over 100 meg because that's just the limitation on the device.
Exactly.
Or the processor on the device isn't great. But then, it's probably on Wi-Fi because like almost everything in my house is on Wi-Fi. So what else was happening on the Wi-Fi network at the time?
Yep.
And then, the connection from the Wi-Fi access point to the router if you have a separate device for that, and then the wire that goes from that to the termination point in your house. And we haven't even left the house yet, and I've come up with like 5 different factors that could be impacting the speed.
Yeah.
And recording all of that has got to be really difficult. Like, how do you record any of that information to make it useful?
Yeah, no, that's exactly right. I mean, you reminded me of a story of, when the New York Attorney General sued Charter, like 2016, 2017, right? One of the parts of that complaint involved speed testing, client-based speed testing. As an expert in that case, I looked at the speed test data, and then we split it out by device, like you said, and then I plotted the distribution of speed tests by speed tier and device. And then lo and behold, like what you said, it's like, oh, well, they're claiming 300 megabits per second. And like these people are only getting 100, like they're getting ripped off or whatever. But then it was like, hang on, let's look at like where the tests are being run. iPhone 5s and 6s, right? I think at the time, right? It's been a while. Well, iPhone 5 didn't have 802.11ac radios, thereby capping the throughput of the radio at 100 megabits per second. And you could see it like plain as day, like when you basically split it out by device. It was like, there it is. All the iPhone 5s like are just like capping out at 100. And I think this is where like data literacy, bringing that sort of technical knowledge and the data literacy together. I mean, that to me, that's like the name of the game of data science. Because it's like, yeah, just some team of folks, they just like take some speed tests and like plot some distribution and like, oh my gosh, it looks horrible. But it's like, no, you have to dig deeper. You have to think about like, what is the system that generated those measurements? And we got to basically understand what's going on here. So yeah, super interesting. It's just fascinating to me. I think the one more thing I'll say about that too is like, this is where like a collaboration with Professor Nicole Marwell has been great, which is that like, I started working on this quite a long time ago, and a lot of this stuff intersects with policy, right? There are policy agendas, right? And sometimes the data is inconvenient, right, for an agenda. It doesn't mean that like personally, it doesn't mean that I'm like for or against the agenda, right? But, someone who's basically trying to make a case doesn't want to hear necessarily that their data sucks. right? Or that the tool
Right.
that they've been using to generate the data for 10 years is broken. And I'm sorry that you'd like to make that point or like sue the ISP or whatever. But unfortunately, the data that you're using is like, basically a dice throw. And so what I find is like, a super interesting part of this is that it's not enough to be like the technically smart guy in the room who knows more about speed testing than anybody else. I mean, that's useful, but also there's governance, right? That's a term that Nicole taught me, right? Is there's a process of governance, which is that like, okay, well, yeah, you're basically saying that, which may be 100% true. And there's like stakeholders here, there's like vested interest. Now, merely by you taking a position, you're like, oh, well, you're just over there with those people. It's like, no, so I think this is actually quite interesting. Like, I think we've learned a lot so far about this and like more to come. Because now, as we're talking about like going beyond speed and like talking about internet quality and quality of experience, et cetera, I hope we do this differently next time around, that we basically figure out like, well, look, this is going to evolve. Much like internet technology sort of overtook rudimentary speed testing. And then we were like, oh my gosh, this is broken. Like this data is garbage. But like everybody had already like dug in. I think now, as we think about quality of experience, application quality testing, I think it's going to be very important to do a couple of things. One, get all the stakeholders in the room, everybody, service providers, ISPs, like NGOs, advocacy organizations, governments, technical researchers, to not only like talk about the stuff, but also to build some trust, right? Because I think everybody fundamentally wants the same thing, which is like we want the internet to work for the applications we use for everybody. Everybody wants to move in the same direction, but like there has to be trust. And then I think the second thing that I've learned from the experience is that we do not know what metrics will be important. I was going to say 5 years from now, like maybe even 6 months from now, at the rate things are going, right? There was no ChatGPT like 2 years ago.
Right.
So it's like, we don't know. And so we have to plan for that. Like speed tests got clobbered, but it took like 5 to 10 years for us to realize its relative small significance in the overall. And now we're like, oh, it's latency, or it's latency under load, or it's whatever it is, responsiveness, or whatever you want to call it. Well, that's true right now, but like in 2 years from now, when it's something we can't even predict, we need to have the framework to adapt what we're doing in ways that like, A, it's relevant to the user's quality of experience, and also B, like people can understand it. Like, I think that's the thing that we're still trying to work on now, because it's like the nice thing about speed, it often doesn't mean anything anymore. But like, it's like, does 800 versus 900 mean anything? No, but like it's a number, people get it, right? I think that's where we're headed to in that area. Some really interesting challenges.
I think everyone listening, and me included, wants to help these projects happen because good data helps make good choices, right? So, for this project and any other projects that you're doing, how can listeners help? What can I do that would improve your data set or help your projects along?
Yeah, I think like one thing, and I assume you have service providers and like internet service provider folks and others listening, is that like we are trying to develop and deploy technologies to improve both the types of tests we run, the data that we gather, but also importantly, how we analyze that data. Right? I think a year or two ago, if you had asked that question, I would have been like, we just need more data. We need to get into homes. Like the Ookla sample is wacky, for the types of questions we're trying to answer. We need to basically do this in a certain way. Another thing that I've done is start a company in this area with my colleague, Francesco Bronzino. And the more we talk to potential customers, the more I realize the problem is not lack of data. The problem is our ability to analyze it, understand it, and produce meaningful insights. And maybe it took me way too long to realize something that to me is now becoming a little more obvious. Is I have been for years obsessed with like, no, we got to get the right sample, and like we got to measure this cleanly, and the technique has to be, it should be like this, don't do the client-based thing, measure from the router. Like, no, we got to basically get into this neighborhood and get like, never going to happen. Like, I mean, it's good for us to like shoot at that target. The ideal sample, we are never going to get it. On the other hand, at the same time, all the ISPs, service providers, even like regulators, there's a lot of public data out there. A lot of it's, just like where we started, full circle, a lot of it's kind of got a lot of garbage in there, but people are going to use it actually, right? Because it's there. And also, like ISPs, service, they all have this data and they're like, Whew. Can someone help us figure out what's going on here? So I think like to your question, Kyler, about like how can people help? I think basically engage, call me, send me a note, send me an email. I'll give you my cell phone. I think basically let's engage.
Mm-hmm.
Because if it were 2 years ago, I'd be like, no, talk to me. Like, we'll basically solve your measurement problems. Now I'm like, no, talk to me, because I think what we actually need to work on together are techniques for developing higher level insights from the data. And forgive me for saying this. I feel like I'm a fairly understated person, actually. So I feel a little awkward saying this, but I feel like the work that we're doing, I'm not aware of like many other people in the world who basically have as much of a lead on bringing multimodal network data to like higher level actionable insights than the group that we have here at the university, and also through the startup company at Microscope. So yeah, please just like service provider, ISPs, et cetera, like reach out on that. I think also from the internet equity side, municipal governments, like anybody listening, like state, municipal governments, especially, like if you're facing funding challenges with like the BEAD program, right? If you're like, man, these maps are horrible, but I don't know how to fix them, or like I'm trying to basically really figure out how to allocate funding, or, you know, et cetera. That is also an expertise that I think uniquely we have, and we want to help. Like, I think you asked like, how can people help us? And actually, I think that basically we just want to help other people. We want to help these orgs. Like in the case of the Internet Equity Initiative, we really want to help state, local, municipal governments, advocacy orgs, whoever basically needs the help with the data problems. We want to help from the company side of things as well. I can see these service providers drowning in data, and like, you know, we all just want the internet to work better. So please just call, honestly. And that's how like I've made progress on these problems for like more than a decade now. Is like somebody calls me up with a problem, and I'm like, that's hard, that's interesting, let's go. So please, hopefully there's a way to like put my contact info on your podcast.
Well, yeah.
Mm-hmm.
We will absolutely include your contact info in the show notes. But for people who are listening and might not be able to write something down right away, what's the best way to reach you? Do you have a preferred social media channel or website or something along those lines?
Like LinkedIn is pretty good. I'm on LinkedIn, like Nick Feamster on LinkedIn. That's pretty good. My email address for like internet equity, for research kind of matters, that'd be like Feamster, like my last name, at uchicago.edu. If it's like a commercial situation, it's like nick@netmicroscope.com. So that's another place. Let's see, other social media. Well, I'm on YouTube. I've got some nice networking videos and,
Ooh.
you know, machine learning videos there, as well as some really amateur rock cover band performances. So you can find me on YouTube.
Wow, that piqued my interest.
Yeah. So
Awesome. All right. Well, we'll include links in the show notes. Nick Feamster, this has been a delight chatting with you. Thank you so much for being a guest on Day 2 DevOps.
Ned and Kyler, it's been a true pleasure. I hope to be back sometime. Thank you for inviting me. It's been super fun.
Absolutely. And hey, dear listener, virtual high fives to you for tuning in. If you have suggestions for future shows, we would love to hear them. Hit either of us up on LinkedIn, or you could send some feedback via packetpushers.net/follow-up. You can find me, Ned Bellavance, blogging over at nedinthecloud.com, and my amazing co-host Kyler Middleton, blogging over at Let's Do DevOps. We're also both active on LinkedIn, so stop by, say hello. Did you know that you don't have to scream into the technology void alone? The Packet Pushers Podcast Network has a free Slack group open to everyone. Visit packetpushers.net/Slack and join. It's a marketing-free zone for engineers to chat, compare notes, tell war stories, and solve problems together. packetpushers.net/Slack. Until next time, just remember that doing DevOps is awesome, and so are you.